get started while we wait for Alex to jump in. And this week's topic, we were going to be talking about final inspection and QA. And that has changed a lot over the last several decades from when I first started in eye care. And the needs have changed, the methods have changed, and there's a lot of various misconceptions out there. So what I wanted to first talk about was the purposes of QA and checking your orders as they come in from the laboratory. And funny little photo there. This is a throwback from quite a while ago, because obviously you see that there's no gray hair in that photo. But that photo I took out of a commercial for my own office that I had quite a while ago. And I'm there at the lensometer inspecting some glasses. Why do we QA? And the reason why, maybe you have a great lab, you never see any issues, you trust them, but you still need to be going over your orders. And it's really about, trying to deliver something to the patient that's accurate and great the first time. So you want to catch any order entry errors. It was our policy to actually take the physical order that we made for the patient and compare that to the glasses to make sure, did we get the transitions on there? Did we get the tint they wanted? Did we have the right frame? Did we have all of the elements there? Because there's a lot of things that your lab just can't catch for you. They don't know if you didn't enter everything into the computer if you're ordering online. They have no idea. They can only process what you send them. Catch lens selection errors. Is it what you wanted? Verify the prescription. There's a lot of human error in that process. You get a prescription from the doctor, you put it in whatever order system you have, you transmit that to the lab. If you're doing all of that electronically, you can cut out a lot of those steps and human error. But if you're still a pretty manual office, there's a lot of room for a plus to be changed to a minus, and a 2 to look like a 5. And here's Alex joining us now from the lab. Alex, how are you?
Good.
So I just basically gave a little intro, and the only thing you really missed was a cutout from a commercial way back when I had an optical store and a lot less gray hair. So
it even looks like you a little bit.
it actually is me. That's a commercial from
Is it?
Yeah, that's a commercial from my store that aired on my local news channel.
There you go.
Yeah. So I'm checking in some jobs on a really, really old lensometer there, you could tell. So we just jumped into the general purposes of QA and how you want to work to keep the timeline intact for your customer as best you can. Deliver a great product the first time that you're confident about, that you feel good about. And from there, I really wanted to jump into, some of the changes, both on the lab side and in the office side of things. So, when I was in a lab over 20 years ago, it's been a long time now, we still had manual blockers for every part of the process. For surfacing, I would stand at the, it was free bond at the time, or alloy, and I would block that lens. I would line it up and, try my best to see the markings and get it where it had to be. Then it would go into the generator. Then I would manually pick a tool to sand it with and polish it with, put that on a cylinder machine. Then it would go after that to someone sitting at a manual lensometer, and they would spin that lens till it was the right axis, put some dots on it. Then they would look their best through their blocker and stick a sticky block on there and put it in an edger. And then somebody would, put it in the frame, and then it would go to a lensometer again, because gosh, there was so much room for human error there. Somebody who had, maybe they had just a little bit more cylinder in their own prescription, and and everything they block is a little, I mean, we dealt with that all the time in the lab. And you're blocking tons of things manually. It's not really that way anymore. A lot of those processes, Alex, are very automated and cuts out a lot of that human error. But we still need a QA, right?
Right. Yeah. And that, I mean, probably the number one discussion with QA is having it in your mind, because a lot of our customers and, talking to other labs, a lot of opticians have it in their mind, and either older opticians that have been in the industry for a long time or newer opticians that have heard from other opticians about how QA is supposed to be or how they believe it to be at the lab. You know, the processes, even within the last 10 years, have gotten so automated. It could be, that an actual human being doesn't touch the order until it gets put into, QA and then get put into the box. Um, so things that we run into, and again, all of these trainings match up together, right? So if you're looking for the lab to QA that possibly, you missed, saying that you wanted transitions on your order, or, saying that, the lab should look to guess if the lenses are too thick, based on what you have in your mind that the lens thickness should be. Those are all things that have gone away, with automated processes. Yes, it's very efficient, very nice that we can do things automated, but we have to remember that those manual processes of QAing through the entire process, it is no longer in the optical industry anymore. It's not manually held by a person through the entire step, which is a great thing. We don't have human error through the entire process, but opticians nowadays have to understand, we're not looking at the order until it gets to final QA. So we're not going to call and say, are you sure that your PD doesn't look very good with this frame? You're going to have really thick lenses. A person may never see that until it gets to the point that the order is shipping. So yes, the automated process is great, but do keep in mind, even though it's automated, we're not touching that order until it gets to QA.
Yeah. Yeah. So it's a very different process. There's still some perhaps using paper orders, et cetera. And in the previous slide, I talked a little bit about, that human error element and eliminating as much of that as possible. But because it's still there, and depending on the processes of your office, your dispensary, there could be more room for human error. So it's still an important process at the office level, because of, however your office may be structured. And I've got an old, lensometer, sphere cylinder lines there. We're going to talk about that a little more later on in some of the following slides. But, lensometers have changed. That's changed how we QA. It's changed the speed of our QA. But there's pros and cons there too. And we'll discuss some of those as we jump into each of these slides. So, from there, just wanted to jump into the first part of what we call ANSI standards. And that's that general power tolerance. And one of the things, there's the picture there of the phoropter, and I like to remind people that the patient made their best decision between 1, 2, 3, 4. A lot of times they weren't sure, they were nervous, they felt like they were making the wrong answer. So maybe they made one that they thought the doctor wanted them to say. Like, it's such a mysterious thing to them, and it's very, very subjective at times. So, remember that when you sit down to QA. I myself, I'm in the range of -8. I wear contact lenses. Every blink, my power changes a quarter. So it's So there's a lot of things to consider. The standards, they're given to us for a reason. And I think some of that, people's perspective on that changed a lot with the digital lensometer. Because now instead of looking at those crosshairs and determining how clear they were on that number you were shooting for, now you're just looking at numbers, and you don't really know, how big is that sweet spot in that lens. You don't know, you're just getting that rough. Sometimes I miss that manual lensometer, seeing what the patient sees, because I think it also helps you understand these tolerances a little bit, because you can move that wheel around that amount of tolerance and it's generally clear on, you know uh eighth diopter above, eighth diopter below. You're like, oh, that's still pretty clear, this power. And so you see those tolerances there. They go from minus 650 to plus 650. You've got an eighth diopter in that range on the sphere power. And then similar things on the cylinder power. You get a little more tolerance on high cylinders. So high cylinders are, instead of an actual diopter amount, they're a percentage amount. 4% on cylinders above 450. You have that diopter value on cylinders under 450. And then with sphere powers, above 650 or above minus or plus 650, it's a percentage of total power there, that 2% factor. So, I used to have a graph on the wall because I don't want to sit there and do what is 2%, but it basically steps up. I mean, you're going from an eighth diopter of tolerance to a quarter diopter of tolerance, on and on and on. And there's so much there that maybe you don't realize in a digital lensometer that you do in the manual lensometer. And why those tolerances grow like that has a lot to do with so many factors. Vertex power is one of them that's huge. You move that lens around in that lensometer a little bit, that minus 10 or that plus 10 patient, just a little wiggle, and you've changed the power dramatically. And so there's tolerance there for that. And that tolerance allows you also to set the vertex distance and do some things there to make that patient comfortable when they walk out the door, and recognize also that this all started at that phoropter. And, you might be really concerned about being on the edge of that tolerance, but you don't know which edge of that tolerance they were on the phoropter. They might have been leaning a quarter the other direction than you think. So I always like to tie that in, because it's a very different process. It's not as, people think it's just rigid and cut, and, but refraction isn't that way. And you're trying to satisfy the needs of that customer. A lot of times I'll flip back and look at their last pair of glasses. I'll look at the doctor's notes in the computer. Maybe they were between this and this. Those are good things to know, because you're trying to satisfy that patient, and you're trying to hit a target. But sometimes at the phoropter, that's a moving target at the phoropter. So it's not as rigid as some people might like to think. Anything you want to add to that, Alex?
Yeah, I think one thing to add, and what we get a lot, and something to keep in mind that, maybe not a lot of opticians know, is, when you have, your lens and your lensometer, and you're looking at it and you're thinking in your head, oh, this is looking like it's a quarter off, or maybe right under a quarter off. The human nature response in your head immediately goes to, oh, there must have been something wrong with the machinery. There must have been something wrong at the orbit that made my lens, a quarter off. And then that leads to doing a remake. It's really, really, really good to keep in mind, as a general rule, that the machines do not create errors, period. We know from Satislow and other industry leaders with machinery that they are accurate to 0.01 diopters on every single order. And they're going to be like that every single time. if there is an actual RX issue, there has been some human interaction that someone messed something up along the lines. And that goes back to our original uh, discussion that this is a completely automated process. We're taking out, humans entirely in the generating and the surfacing process. So, the general rule of thumb that you should say in your mind is, well, I know that this is 0.01 to a diopter accurate. There has to be something else going on here, which
Right.
definitely is. So that's where your mind should go to what the next issue could be.
Right.
Yep.
All right. So that's power. And from there, we go to axis. And, you know, axis is an interesting one because it feels like when you first look at these numbers, you're like, oh my gosh, there's so much tolerance on a quarter diopter lens. I mean, 14 degrees is still intolerance. But if you had used the manual lensometer approach in the past, you know that a quarter diopter, you could actually set your lensometer wheel to the right axis, have it crystal clear, and you can move that lens around and it's still clear. I mean, it's that the hash marks aren't really moving across each other that much until you really get out there a ways. And so, there's essentially you're seeing what they're seeing. And that was kind of the goal of the manual lensometers. You're seeing what they're seeing. You're seeing that it's a tolerable power. And again, remember that old is one better or two. When the doctor gets to the axis part of it, that is a very hard part of the refraction for the patient to answer. And he's usually flipping 10, 20 degrees one way, the other way, and trying to really hone in on what do you like better. The customer sometimes thinks that it's like, well, I have a cold, you give me an antibiotic, it's always that prescription. But in a refraction, it's what the patient told the doctor I like. And that's so foreign to most medical type practice, whereas you're just literally telling them, yeah, this is what I like. And it's such a weird thing. And so axis is so dependent on that. And then it's also so dependent on power. So you see how the chart moves from 14 degrees tolerance to 7 degrees, to 5 degrees, to 3 degrees, to 2 degrees. And again, on your digital lensometer, what you'll notice most is how little you move higher powers, and the numbers on the lensometer go, it's very small movements. And you see that in your manual lensometer, you're seeing it with your eye, how quickly those hash lines move on higher powers and how much less of a tolerance you can have with higher power. You see that when you have that lens in there. And, I think there's a lot of misunderstanding on the weaker powers. And that's where people really struggle somewhat on higher powers, just because maybe they're a little sloppy at the lensometer and don't line things up real well. But on the weaker powers, both with axis, and then the next slide is going to be prism, so much misunderstanding there. In fact, not just amongst opticians, but doctors. When I was dispensing, I would have doctors from other neighboring offices call me and say, Mark, I got a prism problem. Can you help me? And it can get confusing. But just understand that on these lower powers, you can't effectively create power hardly by turning it and changing that. It's such a minute change that it still looks clear in the lensometer, therefore it's still looking clear to the customer. And that's a hard concept for people to grasp, especially with the digital lensometer, because you see these big number differences and you're going, oh my gosh, this is way wrong, way wrong. But it's technically not way wrong, really. Anything that you want to add there, Alex?
Yeah, and I'm thinking in my head back to when I started, in the lab. One of the first things I did was, single vision dotting, and I, always remember all day long going through the orders, and then you finally hit your, minus a quarter sphere, and that is the one as an early
Yeah,
optician that you sit
you're
there
like,
and
where do I
go,
spot this up at?
yeah, you sit there and you go, "Oh my God, what is this?" After, everyone before that is easy until you hit your minus a quarter. And I wish I would have learned a little
Yeah,
earlier
well,
about
yeah,
these.
you hit that minus a quarter, and if you're not
Yeah,
paying attention and you're just in a certain mode of just spotting it when it's clear, if you're
yeah,
the same guy blocking at the edger and then you see the three dots way at the bottom of the lens, you're like, what the heck? How do I block this?
yeah, yeah. Luckily, it's a lot more automated now, but and even back to thinking about that and dotting and then final inspecting, and we talked about this yesterday. I mean, you're never going to remember off the top of your head that a minus a quarter gets 14 degrees of of change or of tolerance. Maybe you will, but it's always a good idea, each of these, print them off, hang them up in front of you. You put
Yeah,
your single vision a quarter in, and it's 10 degrees off axis. Don't immediately, again, in your head, go to there's something wrong. Immediately go to your tolerances. Immediately go to, well, what could it actually be? It's probably
right,
not wrong. What could it be? So print these
right.
off, put them in front of you, and that way
And
you don't have to study them.
if it's a progressive, you're probably just not on the right part of the lens,
Right, right.
because I think what a lot of people also don't remember is that we tend to talk about the distortion off to the sides as just blur, but that blur is technically unwanted cylinder in odd axes and everything else. That's how it manifests. So quite often with a progressive, it's are you lined up with the progressive? And that tends to be an issue too. Some labs throw a little sticky on there ahead of time or something, and sometimes those moved in shipping. Spot the progressive yourself, make sure you're lined up. One of the things everywhere I worked, and it drove some people crazy, but I would lay a standard one size fits all progressive chart next to the lensometer, laminate it to the table so I could set any progressive down, spot my center, spot my prism reference point, which we'll get to in a moment, and just have that quick anytime. Anytime I'm working with a patient, I can lay him down, spot. Always had a marker right there. It was just very convenient for me to operate that way and have one chart. And you don't, there's only so many designs. There's like 4 drop, there's 6 drop, 2 drop. If you've just got one that's got a couple of hash marks for all of those, the general goal is you're just trying to find the center and then also that prism reference point, which generally, most of the time, correct me if I'm wrong, Alex, is on that 180, correct?
Right. Yeah. And what we do, and we stole this from someone else, by the way. So there's a lot of labs that are doing it, and it's really smart. We send you a sticker masking with every order.
Yeah,
We want you to handle that because we we know how important that is, but we set you up for success to get you in the right area. But we want you to take the time manually, an actual, optician manually, to put that sticker exactly where you want it. Because again, in our automated process, there is not a great way to do that. That luckily, that's one of the, things that's left in our industry that
yeah.
needs an extremely skilled, experienced person to do that, and it takes some time. So that's what a lot of labs have been going to, using these nice little stickers, and it's worked very well. Completely axed out any axis issues on progressives that we had in the past. So
Right.
something to think about if that's
Yeah.
not something.
Yep, for sure. So either use those stickers or get you some charts laying around that you can. The one thing I like about the charts is a lot of times they have a monocular PD reference in the middle
Yeah,
section. So once you've spotted them up, you lay the bridge of the frame on there, and then you can quick check your monocular PDs. Hopefully, everybody's taking monocular PDs on progressives. I hope.
yeah,
So it's a great way to check that. It's a great, that's usually my first stop with a patient who says they can't see. If they were wearing progressives in the past, my first stop is their monocular PD. Then I start going through the heights, their power, what they were wearing before, designs, etc. That's a whole other class, but that's typically where I go with that step. And, but take that because you need to be looking at the right spot on a progressive for the power. And then in the next slide, we'll see for the prism, especially so much misunderstanding there when it gets down to prism. And seems like a lot of numbers here in this chart. I'm going to break it down real simple. And, there's vertical tolerance, horizontal tolerance. You might be thinking, why are there different tolerances? There's a number of reasons, but the primary reason is all of us can make ourselves cross-eyed if we want to, but almost none of us can raise and lower one eye. We're always converging and diverging all day long based on distance. So our eyes are able to accommodate more in that direction than in other directions, especially vertical. So vertical prism under essentially everything that's under 3.75 diopters. You're looking at 3/8 or just over a quarter tolerance there. And we'll talk about progressives in a minute. But horizontally, you've got more room there. So you're getting what is that, 5/8 if I'm doing math right, just a little
yep.
over a half. It's Wednesday afternoon, it's too much math, but you're getting 5/8 tolerance there in the horizontal plane. And what people don't realize is, this is your PD tolerance. People don't, in the horizontal plane, this is your PD tolerance. So if you were just quickly spotting up a job and it was that minus a quarter job and you weren't paying attention, you could come up with, any number of millimeters wide or narrow on that job, because you can essentially move that lens around in the lensometer and not really change. It's going to, those crosshairs, those hash lines are going to stay right in the middle no matter where you move that lens, because there's not power in that meridian. There may be a lot of power in a different meridian, but still moving it around may not move that much at all. And so that is your PD tolerance. So what it is hard for opticians to get that. A lot of times they'll spot up and go, oh, the PDs are wrong, way wrong on all this. Well, spot up in one side. This is what I would do. I would spot up in one side that 5/8 out or in, whichever case it may be. Spot that up and see where that is. Do you fall in that range? That is your PD range. Now, when you get up into higher powers, they give us millimeters from pupillary distance, because it's for one, it's just easier that way rather than doing the math. But it's so much more tight of a tolerance in those higher powers. And you see that in the lensometer. If you're on your digital one, again, those numbers are going up really quick when you move that lens around. And if you're on your manual lensometer, you can see how every little tiny bit is moving those hash marks all over the screen in there. And so the tolerances are related that way. And that is how your PD tolerance is on single vision and on the top part of a line bifocal on your distance prescriptions, how they are. So you see that is your tolerance there, that 5/8. But then on a progressive, we have a different tolerance because there's so much else going on. Despite your power, you've got an add power there. You've got this peripheral unwanted cylinder to the side. And so in that case, it relates to that prism reference point, which I have a hard time ever saying. It relates to that reference point, and it's a millimeter of difference in that prism reference point in any direction. So you need to be able to find that. It's on those masks that if your lab is sending you those stickers, it's on those. If you know what your progressive design is, pull out the chart for it. Most of them, again, are on the 180, straight between, halfway between those two dots, progressive marks. But there may be a few oddball designs out there where it is a little different. I don't know of any. Alex, are there any still on the market that are weird?
Not that I can think off the top of my head. No, I know, I know what you're talking about. I remember running into them, but have not had that for a long time.
Yeah.
Yeah, I mean the one thing, the difference between prism and axis, of course, hopefully we explain axis is obviously a lot more flexible in terms of RX. Prism is the one side, and I know I said earlier the machines don't make any errors, but the one error for prism, if you have something way out of line, unwanted blocked in prism is definitely a thing, definitely an issue that the blocking machines will have. Rare, but it does happen. When you see something that is multiple diopters away from what your prescribed prism, or you don't have any prescribed prism and you have unwanted prism, that definitely is from a blocking machine. If you, and hopefully I can, the machine, it's supposed to be like this and it's rotated a little bit that way, that would cause unwanted prism. Again, rare, but something to think about.
Yeah. And you're a little bit frozen on my end there, but just going back to that progressive and understanding that piece too, in that progressive lens situation, you remember that you're checking two places. So you're checking the top part where the prescription for distance is supposed to be, and then you're going down and checking for prism at the prism reference point. So you want to set your table to the bottom of that frame, and after you've set your table to where you're reading the actual prism reference point, you're not worried about power at that point. You're worried about how well you are aligned, and what you're looking for is an imbalance. So with prism thinning today, you may have a bunch of vertical prism, but the thing to clarify is that you're looking for an imbalance. So if it's two up in this side at the prism reference point, should be two up on this side or whatever, you want a balance to be found at that prism reference point. Whatever you're seeing here, you need to be seeing here. And that's the goal of that reference point, so that you see that. So again, with prism thinning, it's going to look weird in a lot of different places on that lens, but the goal is check that reference point. Whatever you have in this eye for vertical, you should have in this eye for vertical. And then you're going to, for horizontal, you're going to be checking, whether the PD is within a millimeter of tolerance and where you are for the placement of that progressive. Thank you for your time. We continue to have these. We will upload them to YouTube, to the channel for POG, so that you can, any staff members that need a refresher on these things, need to comprehend some of these types of issues, don't understand, be sure to point them to the YouTube channel so that they can continue to educate themselves. We have new topics coming out every 2 weeks. And again, thank you for joining us.